Starting with example 4. What is a cubic polynomial function in standard form with the zeros -2, 2, and 3? So we're going to write a linear factor for each zero. Now, what we learned in the previous examples, when we were going the opposite, we were given the factors like this, and we found the zeros. And we noticed that the zeros were opposite of what we saw in each factored parentheses. So since I have a -2 as one of my zeros, one of my parentheses is going to be a +2. And since I have a +2 as one of my zeros, one of my parentheses is going to be a -2. It's going to be the opposite. And since I have a +3, right here, this parenthesis is going to be a -3. So from this, now I have written out the factored form of a cubic polynomial function with those 3 zeros. I don't want it in factored form. I want it in standard form. So to go from factored form to standard form, the first thing we're going to do is we're going to multiply or FOIL the last 2 factors. So I'm going to FOIL my x minus 2 and my x minus 3. Now I am going to keep in mind that I have this x plus 2 right here in front. I still have that factor. I'm not doing anything with at this point. So I'm going to FOIL my last 2 parentheses. So using the FOIL method first, x times x is x squared. And I'm putting this in a parentheses because I still have multiplication to do. I still have this first term to multiply through my quadratic that I'm going to end up with. So my first is x squared. My outer would be x times -3, or -3x. My inner is -2 times x, or -2x. And then my last is -2 times -3, or +6. Okay? From there, I really want to go ahead and combine my like terms in the middle. So I'm going to just erase, since I'm kind of limited on space. I'm going to go ahead and combine these, my -3x and my -2x, add together to become a -5x. Okay? So there's my quadratic inside that parentheses. Now the next thing I'm going to do is multiply my first factor times the product that we just did. So I'm going to take my first term and distribute it through to all 3 factors. And then I'm going to take my second term, my +2, +2, and distribute it through. And I'm going to write everything down. So we're going to see this. We're going to do x times x squared gives me x cubed. X times -5x becomes -5x squared, because again, multiplying x times x, x squared. And then x times +6 is +6x. Okay, so I'm done with that first factor. Or that first term. So now I'm going to do the +2. So +2 times x squared is +2x squared. +2 times -5x is -10x. And +2 times +6 is +12. Okay? My very last step here is simplify. And another way to say simplify would be to combine like terms. If you want to write that in, that's basically all we're doing. Making sure that we are putting our exponents in order from least to greatest. So I don't have any other x cubes, so that would be my first x cubed. Okay, so I have now done that number. I have a -5x squared and a +2x squared that are alike that I can add. Again, remember, only add your coefficients. The x squareds just tag along in addition, in subtraction. -5 plus 2 becomes -3x squared. So I've done those. I have a +6x and a -10x that are alike. So +6 and -10 becomes -4x. Done with that. And I'm left with nothing else besides a +12. So I have simplified. That is it. That is as simple as I can make it. Moving on, excuse me, if you have questions, please again let me know. So moving on to example 5. What is a quartic polynomial function with the zeros? So now we're going to a quartic, which means we're going to have 4. Notice we have 4 zeros. So that means we're going to have something that's x to the 4th. When you have 4 zeros or 4 solutions, you have x to the 4th. Okay, you know we're going to have our exponent, our leading degree is going to be 4 based on that. So write a linear factor for each 0. Again, here are my zeros. So the -2 inside the parentheses becomes a +2. My second 0, guess what? It's the same thing. So I'm going to have another +2. And then this 0 is a +2, so it's going to be a -2. And then this 0 is a 3, so this one's going to be a -3. Again, opposite signs when you're writing them as your factors. All right. If we get to fraction factors, I'll show you a different way that you can do this if you need to. But at this point, if you just have integer zeros, we're just going to go with the opposite of what you see inside those parentheses. So again, it says multiply and simplify. So this is going to be a little more detailed, but I'm going to FOIL the first 2 parentheses, and then I'm going to FOIL the last 2 parentheses. So let's go ahead and FOIL the first 2. So x times x is x squared, and then x times 2 is +2x. Oh, and I need parentheses because I still have multiplication to do. And then my inner, I've done my first and my outer, so my inner is +2 times x again. And then my last is +2 times +2, which is +4. So again, I'm going to go ahead and combine my middle terms here, and for lack of space, I'm going to erase and put them all in this parentheses. +2x and +2x becomes a +4x. I'm going to make my +4 a little bigger for you. Okay, so first 2 FOILed, done. Let's FOIL the last 2. First, x times x is x squared. Outer, x times -3 is -3x. X times -2, this is exactly what we had above. Inner, -2 times x is -2x. And then -2 times -3 is +6. So again, I'm going to go ahead and combine my -3x and my -2x, making this a -5x. This is my squared. Now I've got 2 quadratic trinomials that I have to multiply together. So I'm going to do my first term, multiply it by everything in here, and then my second term by everything in this second parentheses, and then my third term. So we're going to do this really slowly. X squared times x squared is x to the 4th. X squared times -5x is -5x cubed. 2x's here and 1x over here. X squared times +6 is +6x squared. All right, done with the first term. 4x, +4x times x squared becomes +4x cubed. +4x times -5x becomes -20x squared. And then +4x times +6, +24x. Done with the second term. Third term, 4 times x squared becomes +4x squared. 4 times -5x becomes -20x. And then 4 times 6 becomes +24. Okay, let's combine our like terms, and that will be our last step. As I look through here, I don't have any other x to the 4th, so my leading term will be x to the 4th. I have a -5x cubed and a +4x cubed. I think that's all the x cubes I have. -5 and +4 leaves me with a -1x cubed. So done. Okay. I've got +6x squared, -20x squared, and a +4x squared. Okay, so I don't care how you want to do this. You can do your +6 with your +4 and get +10, and then take your +10 and -20 and get -10, or your order doesn't matter as long as you keep your signs. +6 and -20 is -14x squared, and then -14 plus 4 is -10. Either way, we come up with -10x squared. Done with those. Okay. +24x and -20x. Well, +24 and -20 is +4x. Done with those. And then I only have one constant, so I end with +24. We are done. And we came up with a quartic polynomial, a leading degree of 4. All right, this next thing that you see on the sheet, I'm going to let you do that on your own. I'm not going to do that for you, but use a graphing calculator and compare the graphs of both the cubic and quartic functions. You can graph them both when you go to that y equals. You can just put both of them in, and you should be able to then look at them on the same graph. Notice it tells you what kind of scale to use to be able to see them. So use an x scale of 1 and a y scale of 5, and in your standard form would be fine. And I want you to look at how they differ and how are they similar between a cubic and a quartic graph. So, last example before you can start your assignment is what are the zeros of f of x equals x to the 4th minus 2x cubed minus 8x squared? What are their multiplicities and how does the graph behave at these zeros? So kind of looking at this, it says, what are the zeros? Well, first of all, I have to factor. And I want to start out with factoring out something that these all have in common, which would be an x squared. I think it'd just be much easier to say, we're going to say 0 equals, because we're finding the zeros. So I'm going to go ahead and set my function equal to 0. And I'm going to factor out an x squared. Okay, so x to the 4th, if I pull 2 x's away, I'm just left with 2 x's. If I pull 2 x's from negative 2x cubed, I'm just left with negative 2x. And if I pull 2 x's from negative 8x squared, I'm just left with negative 8. Okay, so there's one part done, but now I've got a quadratic inside the parentheses. So I'm going to go ahead and look for factors of 8, factors of negative 8, that have a difference of negative 2. Okay, and I know 4 times 2 is 8. I know 4 minus 2 is 2, but 4 minus 2 would be positive 2. So I need to do 2 minus 4. So my 4 is negative. So inside my parentheses, I'm going to have a positive 2. Whoops. Sorry. I'm going to have a positive 2 and then a closed parentheses. And then I'm going to have a negative 4. Okay. Noticing that these are zeros, and it's a quartic function, and I should have how many zeros in a quartic function? I should have 4 zeros. We should have 4 solutions because of my leading degree of 4. We should have 4 zeros. Well, I only really have 3 terms here that multiply to 0. But notice one of my terms has a exponent of 2. So what that means here is if I set this down here, if I say x squared equals 0, and then I do x plus 2 equals 0, and then I do x minus 4 equals 0, okay? That means that 2 of my zeros are 2 of my zeros of my function are actually 0. That means this 0 occurs twice. Okay, because I have to have, if it were just x equals 0, that means it happens once. If it's just 1x, x to the 1st equals 0, one of my zeros of my function, or one of my solutions is 0. But since this is an x squared, 2 of my solutions are actually equal to 0. Okay, over here I have x equal to negative 2, and then over here I have x equal to 4. So technically, we know we have 4 zeros, but my solutions are 0, negative 2, and 4. But my 0 occurs twice. That's what this is meant by. What are their multiplicities? In other words, how many times does that 0 occur? So this 0 occurs twice, which means this 0 has a multiplicity of 2. This 0 has a multiplicity of 1. And this 0 has a multiplicity of 1. Okay, so however many times your zeros occur, if your zeros occurred 3 times, that would be a multiplicity of 3. Okay, so I'm going to talk really simply about how does the graph behave at these zeros. Well, if you have a multiplicity of 2, or a multiplicity that's even, okay, I know this is going to be an x-intercept. I know all 3 of these are x-intercepts. That means it's where they cross or touch. We haven't really dealt with touching the x-axis and turning around. So an even multiplicity okay, means the graph touches the x-axis, and turns around. That's an and turns around. So I'm going to erase some of this and kind of show you what I mean to kind of give you an example, but I'm going to need some space. So I'm going to erase this right here. I'm going to kind of give you an example. I don't know exactly, I won't graph this graph perfectly, but I'll give you an example of what that would look like. Now, since we know that we have an even exponent and a positive a, we know the behavior is going to be, the end behavior is going to be up and up. Okay, we know the end behavior is going to be up and up. So if this were my graph, here's my x and y axis. I know I have a 0 at -2, and I know I have a 0 at +4, and I know I have 2 zeros here. So I know I'm going to go up and up. So I have no idea exactly how this is going to look, but I know this is going to come and it's going to do something like this, and then it's going to curve and touch and turn around. I don't know. I can't exactly say how that graph is going to look, but it would look something along those lines. It's going to come up to the x-axis, touch it at 0, and instead of actually crossing on through, it's going to turn around and go the opposite direction because of its multiplicity. That's all that's meant by the multiplicities and how it behaves. So if it's a multiplicity that's odd, it actually touches the x-axis and crosses it. If it's a multiplicity that's even, it touches the x-axis and then turns around. Okay, you may begin your next part of the worksheet.